Hi, in this lesson, we're going to talk about probability. Probability is the study of how likely it is that an event will happen. Probability lies between 0 and 1 and can be measured as a fraction, as a decimal, and sometimes can be shown as a percentage between 0 to 100. For example, we can show the probability as a common fraction. In this case, we will have 5 out of 8, or 5 divided by 8, which can be shown as a decimal as 0.2 as 0.625 and as a percentage as 62.5. So this shows the probability scale. If something is at 0, it's likely impossible that it will happen. If something is at 1 over 4, 25%, it is unlikely that that event could happen, but there is a chance. If something is at 50%, then there's equal chance that it could happen and equal chance that it could not happen. If something is at 75, there's a good chance that it could happen. And if something is at 100, then that something definitely will happen. Our probability formula looks at the number of favorable outcomes divided by the number of possible outcomes. We'll take a look at an example later on. In probability, they like to refer to the dice. So one thing you should know about dice is that it has 6 possible outcomes. They like referring to the coin. The coin has 2 sides, so a head and a tail. Therefore, it has 2 possible outcomes. With our cards, we have 52 cards in a pack of deck. A pack of deck has 4 suits, 13 values in each suit. So there are 4 cards of each value. Here's an example. There are 4 twos, and all of them have different colors and have different shapes on them. The 4 suits are diamond, spades, hearts, and clubs. The card values in each suit are starting at 2, 3, all the way to Jack, Queen, King, and Ace of all spades. Let's take a look at this example. It says a card is taken at random from a full pack of 52 playing cards. What is the probability that it is red? So with red, we have your diamonds, which there's 13 of them. And we have your hearts, which there's also 13 of them. So the events is going to be the chances of the event is 26. There's possible 26 outcomes. So we will have that as 26 divided by 52. And that is the possible outcome as a fraction. B, it is a queen. In our cards, we have 4 queens, each belonging to the 4 suits. So the probability here would be 4 over 52. A red ace. With aces, we have 4 aces in total, but only 2 are red. So there's 2 possible outcomes. So that would be 2 over 52. D, the 7 of hearts, very specific on the number and the suit. So there's only 1 card that matches that. So that will be a 1 out of 52. And even numbers. So in our cards, even numbers are 2, 4, 6, 8, 10. So there's 5. 1, 2, 2, 3, 4, 5. There's 5 in every suit. And we have 4 suits. So that's going to be 20 possible outcomes, giving us a 20 over 52. So sometimes we have to work with compound events. In our compound events, we can use a table. You can show the number of possible outcomes for two events happening one after the other using the table. So here it says a coin is tossed 2 times. What is the probability of getting 2 heads? So this is the first flip, and that is the second flip. For the first flip, we have a possibility of heads or a tail. So we will write head here for the first flip, tail here for the first flip. Then for the second flip, we have again the probability of a head and tail. So a head here for the second flip, tail here and tail there for the second flip. Then the probability we'll see it is a 1 out of 1, 2, 3, 4 boxes. So the chances are 1 out of 4 or 25%. We can also use a tree diagram. In a tree diagram, you can list all possible outcomes of an experiment. For example, in a family of 3 children, what is the probability of having 2 girls and 1 boy? So you're going to start with the first one. You only have a boy, chances are boy or girl, right? For your second one, it could be a boy or girl. Or if you had a girl first, then you could have a boy second or a girl second. For your third child, maybe you had a boy as a third child, you can have a possibility of having a boy, or you can have a possibility of having a girl. So it goes on and on in the same way. Here we want to know the probability of having 2 girls and 1 boy. So let's start with the first one and look at it. So for the first one, going from here all the way there, we'll see we only have boys, so it doesn't meet the events we want. Over here, we'll see that it has 1 girl, not something we want. Here we'll have a girl, and then a boy. No, if we start with a boy, then a girl, then a girl. Yes, this meets our needs. And then second, this one here, we have a girl, a boy, and a boy. 2 boys does not meet our needs. We have a girl, a boy, and a girl. This one meets our needs, so we're happy with that. And here we have a girl, then we have a girl, then we have a boy, 2 girls, still meets our needs. And then here we have a girl, and another girl. This doesn't fulfill our needs. So out of how many possibility? 1, 2, 3, 4, 5, 6, 7, 8. We have a 3 out of 8 probability that you would have 2 girls and 1 boy.